Hey, Felice, what are you doing this weekend?
I don't know.
Hey, I found this incredible invention. It's called glow sticks.
Glow sticks, yay! What do they do?
On weekends.
Glow sticks are items that are insignificant, not noteworthy, and often overlooked in our lives. We use and then dispose of them without thinking much about the important chemical concepts and reactions that occur within the glow stick. More than it may seem, glow sticks are sophisticated, convenient, and have a fascinating history of development. The creativity of early scientists and the exploration of chemiluminescence applications have brought one of the most efficient and practical sources of light. The functionality of glow sticks involves complicated glass designs and chemical combinations. However, this small, cheap, and entertaining invention has brought a new hazard and problem to the environment. Non-biodegradable and hazardous to the body, the environment pays a great price for the production of these tools.
The purpose of our lab is to determine the effect of different temperatures on how long a glow stick lasts. Our independent variables are the temperature of water surrounding the glow sticks. Our dependent variable is the amount of time which the glow stick lasts or until it loses all glow or ceases to produce light in the number of minutes. Our controlled variables are the environment in which the tests are conducted, the conditions in which the tests are conducted, a consistent method of timing, amount of glow stick substances, same pressure for all glow sticks, and the same colored glow sticks.
The materials that were used in this project were 9 glow sticks of the same color and same size, 2 cameras, 3 250 milliliter beakers, 3 500 milliliter beakers, 500 milliliters of 70 Celsius water, 500 milliliters of ice cold water, 500 milliliters of room temperature water, 1 hot plate, 3 thermometers, 1 stopwatch, paper tape, 1 permanent marker, 1 bag of ice, and 3 tweezers. First, the camera for recording the time each test tube glowed and the camera that recorded the process of the experiment were set up. Next, 9 identical glow sticks of the same color and size were selected. This was to ensure that our controlled variables of the glow sticks stayed the same. Then, the glow sticks were labeled 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, and 3C to help organize the data. In addition to the above materials, 3 500 milliliter beakers labeled Trial 1, Trial 2, and Trial 3 were taken, and 3 250 milliliter beakers labeled 1 final, 2 final, and 3 final were selected, then put aside for the later stages of the experiment. Next, the beaker labeled Trial 1 was filled with room temperature water, and the beaker labeled Trial 2 was filled with ice cold water. Ice was added continuously to beaker Trial 2 to keep the cold temperature steady. Then the beaker labeled Trial 3 was filled with room temperature water and then set on a hot plate to be heated till the water rose to 70 Celsius. Thermometers were then added to each beaker to identify and record the contrasting temperatures. Afterward, all glow sticks labeled with 1, which included 1A, 1B, and 1C, were placed in beakers labeled Trial 1. The corresponding glow sticks were put into their corresponding beakers, just like it was done above. All glow sticks were made sure to be placed in the different temperature beakers all at the same time to ensure that data would be consistent. Next, all the glow sticks were left in the beakers for 45 minutes so the reaction between the glow stick and the water had time to occur. After 45 minutes, the glow sticks were taken out by tweezers, then placed into the corresponding beakers labeled Final 1, Final 2, and Final 3. For example, glow stick set 1 was placed in beaker labeled Final 1. Next, the 3 beakers, Final 1, Final 2, and Final 3, which held 3 glow sticks each, were transferred into a dark cupboard, where they remained for the rest of the lab. This was so that the environment in which the glow sticks were kept in was the same, hence ensuring that our environment variable was controlled. Finally, the recording camera was started and the data was written all down.
Should we take it out first?
The procedure adequately addresses the purpose and question of how a glow stick's different surrounding temperature affects how long it lasts. This is because an adequate 9 trials were conducted, 3 for each temperature. Our procedure included 3 glow sticks being placed in a certain temperature water, 25.5, 0.7, or 70 to 80 degrees Celsius water. Our controlled test was with 3 glow sticks, where the glow sticks were placed in room temperature water so that our final results could have a standard or a set of results to be compared with. Next, sets of 3 glow sticks were placed in 2 different temperature water. One set of glow sticks were placed in 0.7 degree water and another in 70 to 80 degree water. This stark difference in contrast in temperature greatly helped address the purpose in question. This is because the results of the cold and hot water were then compared to the results of the room temperature water, our controlled test, to show the effect of a glow stick's surrounding temperature on its ability to produce light. Our procedure also helped address the question because our procedure was designed to ensure consistency in our controlled variables. For example, in our procedure we made efforts to keep a consistent method of timing, amount of each substance, same type, color, length, and size of glow sticks, and a consistent pressure and condition of the environment. A requisite amount of trials were conducted to support our purpose because the 3 glow sticks or trials of each test was to ensure accuracy of results and was enough to support our hypothesis. For example, one of our trials failed, but despite this setback, we were still able to gather sufficient data because of our other 2 successful trials for that test. Another reason why enough trials were conducted is because it helps ensure that our results were accurate and not outliers or failed trials.